Okay, so fortunately, we recovered the file that we were missing. What is today? 27th, 28th, 27th, where are we? Today's Monday, Wednesday, 29th. Here it is, unemployment. No, Schedule 2. Today's not Monday, today's Wednesday. Anyway, Schedule 2 is the one that we need. So let's go ahead and get Schedule 2 downloaded, which I think I've downloaded, and open it up. This is where we'll do our work for today. So today we'll see a couple of things that are new, but today is really an opportunity for us to kind of cement some of the things that we've learned, as well as kind of get the feeling for actually solving an interesting problem. So some of the days we spend is just like, here, look at this snippet of code, look at this snippet of code, look at this snippet of code, and you find yourself wondering, how do I ever use this on something meaningful? And so today we're going to solve kind of a real problem. Now, professors actually, almost everything you see a professor do is you see a professor teach. And so if you're like me, when I was a student, I thought that's all those guys do. But there's two other major responsibilities that we have. One is research. So, you're expected to be doing research that gets published in respectable outlets. And the second one, I guess maybe the third one, is that we have service to the university. So part of my service responsibility is that I am the academic scheduler for the Marriott School, which means that ultimately I'm the one who has final say about what class gets taught in what room at what time. Sounds like a whole lot of power, but the truth is the departments choose when their classes are going to be offered, and I only have to get involved when I've got two departments that are saying we absolutely have to have that classroom at that time and no other time will do, and the other department's saying the same thing, and that's when we put them in the ring and sell tickets and just let them fight for it. I'm the guy selling the tickets, to that show. So, but scheduling is really a challenging problem. Now, this is data that I must have pulled in fall, so I probably pulled this in 2018 for this example. But I think these are actually classes this is probably every class that was offered by the accounting department. I might have filtered it down to just some that have a particular characteristics that I wanted to look at. So for all I know, these might have been some of your classes. Any of you in the junior core in 2017, fall 2017? Any accounting students? Yeah. Okay, so this is some of these are your class. So you would find the class that you're in and you would know, oh yeah, that's really when it was, and that's who taught the class, and that's the room that was in, and so forth. So it turns out that all the data one of the things that's kind of my responsibility is to make sure that we don't have two departments that have inadvertently scheduled the same class for the same time. Now, it happens that this class right now, we actually have two different classes happening in this room at the same time. How many of you are taking MBA 614? See, there's a few of you, and then most of you are taking IS 520. So you're registered for two different classes. They are here in the same classroom at the same time. That's okay. But if we had two different classes in the same time at the same room, and two professors expecting to teach two different classes, that would be a problem. All the data that we need to know is, are there any classes that are overlapping each other? It's all right here. I mean, here it is, right? I have the days of the week that this class meets. I know when it starts and when it ends. I have the room that it's meeting in. And so it's all here. But how easy is it for me to be able to look at this and be able to say, oh yeah, those two classes are in conflict with each other? It's really, really difficult. So the information is here, but it's not presented in a way that we humans can deal with very well. I mean, we can, but not very well here. There's another kind of issue besides just what I look at this data for. So you think about the folks that are in the accounting department that are trying to decide when they're going to offer all these classes. Some of these classes are only offered once a semester or even once a year. So let's see if we can find one. It'll be a higher level number. IS 556. That is only offered one time this whole semester, and it's offered Tuesdays and Thursdays. IS 557, oh, look at this, is also offered only once. And look at this, those two classes are at the same time. If you want to take both those classes, what's the answer? You can't. What'd you say? Clone yourself? Someone say clone? Yeah, you are out of luck here. And so now, are there going to be times when we have two classes only offered once that they're going to in conflict with each other? Yeah, but we want to make sure that we have managed that. And say, you know what, these are classes that the same folks are not likely to take. So there might be a few people that are upset by that conflict, but we definitely want to make sure that it doesn't happen with stuff that's going to keep people from graduating. We'll keep you here an extra year just because you couldn't take your last requirements because we don't offer them We offer the only two offer at the same time. So that's actually probably more relevant to this because this is accounting. This is data just from the accounting department, and we want to be able to make that in such a way that they can look at it and say, okay, what's being taught at the same time on Mondays? And can we live with those kind of scheduling conflicts? Even though they're not happening in the same room, they're happening at the same time. So you can see I kind of have this problem set up that I've got this area over here that I'm just going to use to make a graphical representation of this data. So what I want to do is I want to look at this class right here, and I want to schedule it into this little time block. Let me hide some of these that are not especially relevant. I don't really care about the professors here. I mean, I care about the professors deeply, but not for this example. Didn't I just say hide? Oh, I said unhide. Hide. There we go. Okay, so now I think we can see this a little bit better. Okay, so here I have accounting 241. That's business law. And it starts Monday, Wednesday. Well, Monday, Wednesday doesn't matter because we just have the times here. But 12:30 p.m. Oh, this is interesting. To 13:45 p.m. If there was some question about where the 13 was, it's in the afternoon. Anyway, probably just a formatting thing. Okay, so what I really want to do here, 12:30, where's 12:30? So there's 12:30. So it starts at 12:30 and it goes to 1:45, right there. Oops. 12:30 to 1. This mouse is absolutely fantastic. There we go. And I would like to give that some color. I don't care what color. Dark red. Blah. Oh, that was the font. There we go. Okay, so now I can look at this. I've changed this information that's just text. I've turned it into a graphic. I've taken what was even temporal, time-based, and I've made it spatial. So I can look at it. It's tough to see time, but I can see spatial stuff. So I've turned that time into a spatial representation. We'll do the same thing for this one. This is 8 to 9:15. And so that's this area here. And I'll color that one. So this is what I would like to do. I would like to take that text data and put it so I can visually look and see, kind of run down this column and say, okay, who's intersecting here in the 11 o'clock hour? And I can look at those classes and say, is it okay for those to intersect? Or do we have to think about adjusting the schedule? So that would make this part of a person's job much easier to be able to see it. So that's our goal for today. Should we do it? Yeah, let's do it. All right, so opening up the code, and we've got enough room here. Let me just kind of get to where we can see part of these numbers at the same time as we're seeing the code. Don't think we're going to need much with these properties. And I can probably scoot that over just a bit more. Ooh. This is the mouse that I love. Okay, that'll do the trick. All right. Wow, we got a blank page. Well, at least we have the sub-procedure already kind of started for us here. But how are we going to do it? How are we going to do this? All the data we need is there, but we've got to come up with a VBA code. We'll make those go over there. You know, it's not like click, drag, and chart. It's all us. Question or suggestion?
Well, just like, I would assume the way the structure is the way we do it, we just do one example, for the work for one, and move it over. And what we're going to do is we're going to reference the times, and we're going to say, like, use this, find its relative cell over in this range, and then change the property of the cell for it to highlight it.
Okay, yeah, so you thought through this pretty well already. So first thing that I want to point out that you suggested was, listen, let's not try to solve the whole problem. Let's try to solve one. Let's just do one. And once we can get one, if we're thinking about doing one in such a way that we might be able to generalize it to do multiple ones, if we got that in mind, it'll be a pretty good way to start. I'm actually going to start the other way. Let's write the loop first, and then let's do the one. But splitting it up that way is a really good thought. And then you said, all right, well, we've just got to somehow convert that number. This, when we see right here, we've got to start time. We've just got to figure out which column that belongs in. So let's go ahead and go down that road. Let's start by making the loop. So this is a review of the stuff that we did last time. What do you think, looking at this data, what's a good kind of loop to do? We got 3 loops. We got the do loop, we got the for next loop, and the for each loop. Which one do we like? Yeah, do loop's pretty good because it's not a fixed number of times. The next time we run this, it might be more or less classes. And so we could make it work with a for loop. We could make it work with a for each loop, but the do loop seems to be the one that's the most naturally suited for it. So let me just declare a variable. I'll call it r as a long integer. And set it to an initial value, r equals 2. We're not going to be worried about that header row. Our first data is in row number 2. And then we'll have a do and a loop. Oop. I'll do a do events in here straight away. I'll do something to get myself out of the loop, so increment r. And then better somehow look at r. What's the name of the sheet? I already said we weren't going to look at this, but I need to know the name of the sheet. Well, that's the properties, so what do I got to do? View, Project Explorer. So this sheet, sheet 1, actually has a code name also of sheet 1. Let's just use that for this code. That'll be okay. So I'm going to do until sheet 1 dot cells, row number, row, column number 1 dot value is equal to a 0-length string. So we're going to just continue to loop until and we're not actually selecting a different cell, but we're going to, I'm sorry, not row, but R. Yeah, you're all row, what's row? So R will be 2. So the first time we're looking at row 2, column 1, we're asking is it blank? Look way over here. And we go, no, it's not blank. So in the loop, no, it's not blank, in the loop. So we're moving down by 1 each time. We're not selecting that cell, we're just referring to a different cell, right? Because as R goes up, the variable goes up, this expression will be referring to a different cell each time. Am I ever doing anything to change the active cell? No, I don't care where the active cell is. I'm not changing the active cell. I'm just saying these are the cells I want to look at, and we'll look at them. Okay, so let me just to make sure I've got this working, let me just print this expression and make sure that it is giving me what I want. So I should see this. The important part is that this shows me some data and it doesn't run on forever. So debug.print, let me print R, comma, that value, and I'll run this. Yeah, so I got down to row 55. That must be where the data ends. And that first column is just the year, so it's pretty boring. But yeah, it goes from 2 to 55, and it's printed the 2017. That looks great. Okay, so now what I'd like to do, and it might be tempting to say, great, inside this loop, let's do what we want to do. But for development, it's going to be much easier for us if we split this into 2 different parts. So I'm going to put this one, I can put it above or below. I'm going to put it above. I'm going to make a sub called show 1 class. Now this is pretty similar to the project that is due tonight, because in that one you said, listen, you've got one that's going to get the data for the active cell and move down, and another one that's just going to tell it to go over and over and over again. Now this one we're doing without the active cell, so we need some way for this one that's going to process just one, we need some way for it to know which row to work on. And we could do it with the active cell, but I would, if we can write this in such a way that we don't have to worry about the active cell, because if you got code that worries about the active cell and the user does something to the active cell while it's in the middle of running, it could do something very, very unexpected. So I prefer to keep off of the active cell if I can avoid it. And so we're going to do something with these parentheses that we have never seen before. These parentheses right here allow me to declare a variable inside these parentheses. I'm going to do it right here. Dim, I'm going to call it row as a long integer. When I declare a variable inside these parentheses, something magical happens. Well, first of all, it's syntactically incorrect. So if I try to leave this, it's not going to like it. But the point here is that the only thing I can do inside these parentheses is declare a variable. That's all I can do here. And as a result, the keyword dim is not only extraneous, it's not allowed. But that's what I'm doing. I am declaring a variable inside these parentheses. Now, when I put a variable inside these parentheses, it behaves a little bit differently than a normal old variable. Normal old variable, you've got to do something that says, this variable equals some value to give it a value. This is going to get its value when we call the procedure. Watch this. Let me just do a debug.print of row So all this does is it's going to print row. And now I'm going to call it from the immediate window. I'll come to my immediate window, and I'll put the name of it. By the way, when you create a subprocedure, it becomes a statement that you can call directly in VBA. It's a block of code that does something, and its name actually becomes a valid token that you can use to refer to it, just like any of your other statements inside of VBA. So like debug.print or do events or loop, those are all things you can refer to directly. This procedure is now as well. So now it's expecting, because it has this parameter here, it says, listen, if you're going to call show one class, you got to give me a value for row. I'm never going to have a line that says row equals, because I'm going to give it its value right here. So I'm saying call this just in the same way that when we, like, say, refer to cells and we give it some value to work on to tell it how to behave. Same thing here. We're calling this subprocedure and we're giving it a value to tell it how to behave. What's that going to print if I execute that? That's going to print 22 because I put the value here on the line where I'm calling the procedure, the subprocedure, and that value then gets written right into here. If I want to, I can give it a name. I can say row colon equals 22, and that will do the same thing. But when it's only one value, we tend to just say, just put the value. That's all you need. Questions? Yeah.
What is colon operator?
So imagine that I had, the question is, what's the colon equals for? That seems so strange and wonderful. What is it? Let's suppose I didn't have just one variable declared. I had 20 variables declared here. And I'm not going to show you how to do this today, but I can make some of those optional. You don't even need, this is going to run just fine without it. You're going to need these. But when I have like 20 different parameters, did I tell you the name? Did I tell you that when I declare a variable there, it's actually called a parameter? It is a variable in every sense of the word. It still is a variable, but it's also gives us the name of a parameter. So I have 20 different parameters, some of which are optional. I don't want to have to and I could skip them by putting commas. I need the first one here, and then I need the 20th one. I got to say, you know what, ignore all the ones there, and then put 3 as the last argument. So because that gets ugly, they say, all right, if you've got, another way to do it is to say it doesn't really matter what order you put them in. You can tell the name of the parameter, and you're not really setting, at that point, you're not really setting the name equal to something. You're not setting the variable equal to something. It's just the name. You're binding the name onto that value. So that's why it's a colon equals instead of equals. Colon equals goes way back to the early days of programming. Pascal, that was the assignment statement in Pascal. That's the assignment statement in Oracle's PL SQL. I mean, that's kind of a normal way to do assignment. It's different in VBA, but that's why they used it. It's one that's kind of been around for a while. So it really just allows you to name, to pass that value in by its name so that the order doesn't matter. In this case, there's only one. And so, yeah. Okay. So, and if we put 12 there, of course, it'll print 12. It's just all it's doing is it's taking that value that I gave to it, writing it into this variable, and now inside this subprocedure, that variable has that value. Okay, how many of you are looking at this going, that is pretty easy? That's 5. You're showing me a 5. If you're going, oh, this is mystical, like witchcraft of some kind, you're going to show me a 1 or even a 0. Okay, so it's okay to be a 1 or a 0 right now. We're going to be kind of working through this and working through some examples. We'll do several other examples where we do this. But this is similar. Let me try to show you kind of what it would be similar to. Let's suppose that I declared this in here. Dim row as long, and now I'm going to say row equals 12. So now if I just run this procedure, it will print 12 right up here. You see this. I've declared a variable, I've given it a value, and now I'm printing it out. And if I call it, I no longer need to have the 12 there. I can execute it up here. By hitting enter on this line, it'll say run that subprocedure, and it says, yeah, great, there's a variable, we're giving it a value 12, and we're printing it out. So what we're doing here is we're saying, listen, it's just a different way to get its value 12. We declare it up here, and because it's declared there, now it will take its value at the point where it's called. So now when I execute this, first thing it does is it says, put the value 12 in the variable row. We don't have a line that does it. And the whole reason here is that this will now allow us to make a general procedure that says, I don't care what row it's going to be on, it's going to do the same thing. We'll schedule row 12. Give me a 12, I'll write row 12. You want to schedule row number 30? Great. Tell me 30. I'll write out row 30. I'll read the data off of row 30. I'll write the little graphic bar into row 30. Does that help to see it that way? Okay. So that's what that is doing. So now let's just go ahead and do it right here inside of our make schedule. So make schedule has that loop, runs through all the data. And I am going to tell it, instead of printing, I am just going to call one class. And let me just put 12 there to start. So I've got 12 there, and I'm going to run this. I'll press F5 to run that. And it's going to print 12, 54, some 54 times. But what do I really want? Instead of sending 12, what do I want to send? Yeah, I want to send R. So the first time it calls, it'll send a 2. Then it will send it a 3. Then it will send it a 4. And so now this is now getting run 54 different times with a different value each one. So if I write this code right, it gets called with the 2, and it should schedule row number 2. It gets called with the 3, and it should do row number 3. But the nice thing here is now I've separated the logic from this loop to say, look, loop, I got the loop down. This is the easy part. Making the loop's the easy part of this project. So let's get that out of the way. And now we can just focus on what does it take to do one, just as the student suggested. Now, we'll do one more thing here. And that is, watch what happens if I try to run this one by itself. So I got my insertion point is right in here, and I'm going to push play. And it's going to go, I don't know what you're trying to do, but you can't run this. Why can't I run this? Yeah, for this to run, I've got to give it a value for row. And if I just hit play, there's no way to give it its value. And so it says, it's trying to be helpful. You can't run that. Here's some you can run. Maybe you want one of these, but you're not running the one you asked for. Is that helpful? I'm not sure that's helpful. But we're going to take advantage of it. Here's what we're going to do. Now, it's hard to tell that these are in alphabetical order when there's only one. But it is in alphabetical order, yeah? And if there's more, you could tell they're in alphabetical order. So what I'm going to do is I'm going to make another sub-procedure here that is alphabetically small so that it will show at the top of that list. That way, when I try to run this one by mistake and it says, here's some you can run, that will already be selected. So I don't have to mouse over and choose which one. I can just hit enter and we'll be off and running. So for that reason, I'm going to call this, hearkening back to Wile E. Coyote. And by the way, what was Amazon before Amazon? Do you know what it was? If you ever watched Wile E. Coyote and the Roadrunner, you would know. Acme, right. I don't even know what Acme is, or Acme, A-C-M-E. I know what Acme is. I'm going to call this the Acme Sub Runner. And it's called that just to start with an A. So that when I'm down here and I press F5, that's the one that's default, and I can just hit enter to run it. And now inside this, I'm going to put a call to the one that I'm working on, and I'm going to give it the value that I want to start with. So this is really only for debugging purposes. So now I can run this one. It's going to go ahead and call this and send a 2 down, so I know I'm working on row number 2. I can very easily now change this to row number 3 and see what happens on row number 3. But the nice thing is here, I don't have to try to loop through things and stop at the right place. I can just kind of directly jump to the row that I want to do while I'm developing it to see how it goes. Okay, so kind of a lot of effort to get the problem set up, to get it configured. But now I think we're in good shape to say, let's talk about what does it take to actually look at this data now and say, we're going to highlight a particular cell. Okay, so someone talk to me now in terms of an algorithm, a set of steps that will help me get here. Let's kind of look at this by hand a little bit more first. So here's one we've already, this is not quite big enough. I'll make this just a little bit bigger so that we can see the start time and we can still see where that bar goes, at least where that bar starts. Okay, that's enough, where the bar starts. So now when I'm here at 12:30, I've got to be column AG. What is AG? see, Z is 26, looks like 33. AG is 33. How do I know that? I just taught this lecture an hour ago. But I made that the active cell. If I was really trying to figure it out, I would just highlight the active cell and I would say active cell dot column. And it'll just print the column of the active cell. You can try to sing your way there, but you A, B, C, D, E, you get to Z and you're stuck. You don't know what to do for AA. There's no music for the second verse. So that's it. We got to look at 12:30 start time, and we've got to convert it to a 33. We've got to look at an 8 o'clock start time, and we've got to convert that to a 15. O is 15th letter of the alphabet. That's column 15. How are we going to do it? And by the way, this is what makes this class different than most of the other classes you've taken at university. Most of the classes you take, they are of one of two characteristics. They are, well, maybe not most. Anyway, a lot of classes are this way. It's like, here's a bunch of stuff, new stuff for you to memorize. And you get the class, man, this class is like all memorization. Or it's like, we're going to teach you how to solve a structured problem. Here's a problem. You understand how the problem is set up, and here's the steps you apply to solve the problem. This is all your math classes. Once you identify the kind of problem it is, here's the steps you apply to it, and that will come up with the correct solution. This is an unstructured problem. Meaning, you know the start state, blank, right? The thing's blank here, we got the data, but the image part is blank. And the end state is clear. I gotta put bars. I can figure out where those bars go, but it's unstructured because there's no algorithm that you can memorize that will do that for you, right? This is a really creative part. You gotta look at it and say, I got several tools here. How am I gonna put these together to make that happen? So it's a different way to think than most of the classes you've taken. Go ahead.
But just like hazarding a guess, we know all of our times are gonna be 8 at a certain time. We know that 8 is the first row, and the row number is, I don't remember what
15.
15, so 8 plus whatever equals how many rows?
How many columns?
Start. Yeah, how many columns?
Okay, so don't say any more. So far, so good, but let me kind of bring us all up to where you are. So the thought here is, listen, everything that happens before column O, or before column O here, is irrelevant to this. We're not going to be putting any bars over here in column I. So let's say that, let's start off by saying, let's just identify where we're starting, kind of where the start, why don't we call it this, where our calendar starts. So I'm going to make maybe even a constant. I'll call it cal start. And I'll set that equal to 15. We could just leave the 15 in our code and say, all right, 15 is going to be where we start, so we've got to add 15 on it, or we either have to add 15 or subtract 15. But if I make this into a constant, then let's suppose, what are we going to do when all of a sudden we got to look at the ROTC class? What time does ROTC classes start? Like 6 a.m. Makes the classes start at 6 a.m. like the Air Force does, the Army does. And so at some point, we might have to adjust that. And it would be great if instead of having to look through all of our code and say, let's see, everywhere we use 15. Oh, but wait a minute. It's not everywhere we use 15 because 15 is also going to be relevant in this example for something else. What is it? What's the other place that 15 is going to raise its head? These cells are how wide? How many minutes wide are each of these cells? 15, yeah. So I'm going to have 15 showing up in two different places. One that I'm using to adjust how many minutes per cell, and the other one where this thing starts. It's coincidentally 15. If I just leave both of those 15s in my code, when I have to come and adjust this to go, oh yeah, now we're starting somewhere different, all of a sudden, I don't know which 15s, I got to really think hard about which 15s I got to change. But if I say, you know what, this is the column the calendar starts in 15, then I can use this everywhere I would use that 15, and I just only have to change it once. So that's good. Okay, so that's the first thing you said was, let's start ourselves, let's get that, let's kind of simplify that part of the problem. And maybe we haven't simplified it yet, but we've started in that direction. So now what you're saying is we need to know, ultimately we've got to get to which column this is, but now it's just going to be a certain number of columns from column 15, where we're starting. So we've got to come up with a starting column. Ooh, I'm not quite sure how we're going to get there, but I can see that we need a variable called start call, and I'll make that as an integer. Yes?
Can you briefly say, like, I mean, I can understand the constant is like a variable.
Oh, what is a constant? A constant is exactly the same as a variable, except once you give it its value, you're not allowed to change it. And as a result, you can give it its value on the same line where you declare it. Now, you can, it's syntactically valid to say as a like byte in here, and then say equals 15. That's okay. But the truth is, the interpreter can look at this and go, I can pick a data type for that, because it's not going to change. It will pick an appropriate data type. Will it pick byte? No, I think it'll pick double. It's a little bit lazy that way. It just goes, no, I'm not double. It'll do like long integer. But for constants, I'm not so concerned about the type because they're not going to be changing. The type, you got to think about the type because you got to say what kind of value is going to go into this. I got to make sure I have the type right. Here, it's one value I don't have to worry about. So it is a named location in memory, the same way a variable is, but you don't change it once it gets its value. Okay. So I think maybe something else that might be helpful for us, just to make this, we could do it without this one, but I think to make our code a little bit easier to read, I'm going to have something called the start minute. So I'm going to figure out what minute this class starts at. Okay. So what do we have here? So I'm gonna run this, and I've got to figure out the starting minute for this. Actually, let's not call it start minute. Let's call it just this. Let's simplify by saying the start time. I've got start time over here in a cell. I could refer to it just by the cell, but referring to this value in the cell is going to be pretty long. I got to tell it what sheet it's on. I got to tell it the range. I got to tell the value. It's a long expression. And I'd rather kind of put that right here into the start time. So let's start off just by getting that into a variable. So, oops, let me do this after I've declared these variables. Start time is going to be equal to, now, the row is being passed in here, so I got to get this value right here. So what am I going to do? Well, let's go ahead and say the sheet, which is sheet 1. And then we want cells, row number, row. I'm not sure which row it is, but whatever row gets passed in, so if this 2 gets written into this, I want that to be the row I'm talking about. Which column am I interested in? Column I. And remember, I can actually put in, I'll use a lowercase I because it looks more like an I in this font. I could put 9. I mean, 9, I is the 9th letter of the alphabet, so I could put a 9 there, or I can just put I, whichever one you please. And then I want the value. All right. Let's go ahead and also make one called start minute. Start min. And I'm going to want start minute to be not how many, not the minutes of the hour, but I want this to be how many minutes have elapsed since 8 o'clock. So if I have start minute of 0, that will be here. If I have start minute of 270, I want that to be somewhere way over here. So the question is, how do I get from my start time now to my start minute? And this is going to be something that you haven't seen before. So let me comment that out so I can play with it up here in the immediate window. There is a built-in function, part of VBA, called date diff, D-I-F-F. The first argument is, what kind of precision do you want to know this? Do you want to know how many days are between 2 other dates? Do you want to know how many seconds are between 2 other dates? Do you want to know how many, I think I can say year. I think year is even a valid thing here. So if I'm looking for days, let me just put day in there, and then we put a couple of dates. Let's do January 1st, 2000 to January 1st, 2020. That is 7,305 days. Do you want to know how many weeks it is? It's that many weeks. You want to know how many years it is? It's that many years. So, oh, it's not that many years. That must be capital Y? I don't know how to do years. We'd have to look it up. Is it 4 Ys? I'd be surprised if it's 4 Ys. It's 4 Ys. 20 years. Okay, so, okay, so how about how many hours? It's that many hours. How about how many seconds? It's that many seconds between those dates. How about how many minutes? Ah, that's months. So how do we get minutes? N gives you minutes. And just, kind of learning how the function works. You pass an N into it, and then 2 other dates tells you how many minutes. Now, incidentally, you can do that between, 2 times. So I could say this is at 8 o'clock a.m., and that'll tell me it's 480 minutes between, oh, I didn't tell it a time on this, so what time is it? Midnight, the very first instant of the day. And so that's how many minutes it is. So the point is, even, and if I, by the way, on these dates, if I don't specify a day, it actually assumes, just like if I don't specify a time, it assumes midnight. If I don't specify a day, it assumes December 30th, 1899, which is day 0. Day 0. I don't really know what classes were being taught in 1899, but I don't care. It's only the times that I care about. So it turns out there's the same number of minutes between 8 a.m. and noon in 1899 as there is today. Maybe not the same number of seconds. I was really surprised to find out that every so often we have a leap second. Have you heard of this? I'm not sure exactly why it happens. It's like you hear in the news, and today we have a leap second. I'm not sure how they decide we got to have an extra second. But they do. They pop an extra second into the day. Oh, I can use a few extra seconds today. Hope it's a leap second. Okay. So that's what date diff does. So we can now use date diff down here. Date diff, and we want the number of minutes between our starting date, and we could make a function for this, but I mean, we could make a constant for this, but this is going to be a little bit more simple than that 15 minutes. I'm going to go ahead and just make that 8 o'clock a.m. We might end up needing to change where the calendar begins, in which case we'll have to come and change this, but I think that'll be okay here. Some would argue you should have a constant for that too, so they're all set up at the front, just change them there and the whole thing will change, but it makes the code a little bit more abstract and harder for us to follow. So date difference between 8 o'clock a.m. and what? Start time. All right, at this point, let me go ahead and print off those 2 variables. My start time and my start min. So I should be able to now call my Acme subrunner and have a type mismatch. Dim start time as, oh, start time should be a date. I'm not sure I made an integer. Start minute should be an integer. Start time should be a date. Okay, so now my start time is 12:30 p.m. That's right, there's my 12:30 p.m. And that is 270 minutes from 8 o'clock. That sounds about right, 270 minutes. So great, so now the only one I have to do from here is I got to get my start column. Whew. How am I going to get my start column? Divide by 15. Take my start minute and divide by 15. Let me go ahead and print my start column out here as well. And I'll run this. Uh-oh. column number 18, this is 15, 16, 17, 18. That's telling me column R. That's wrong. What am I missing? Yeah, I'm starting way back there in column 1. I got to add in where I'm starting on my calendar. So I'll take my cal start and add that on here. Now we'll run this again. Ah, and there's my magical column 33. Ah. Kind of amazing, right? I think through, pick it apart and think. And we did this on the first shot. Why did we do it on the first shot? I've done this example dozens of times. I knew exactly the right road to go down. You think you go down the right road the first time you're doing it? No. You try something else, you go, oh, that's not it. No, that's not working. And we'll try something else. And that's the way it goes. Do you think I, even in my advanced experience in VBA, often like go down the wrong road and go, that's not working, try something else? Oh yeah, every time. Every time I go to something that I haven't solved dozens of times before, yeah, it's the same thing. Okay. Oh, one time I actually looked at the feedback that my students gave me at the end of the semester, which before I had tenure, I looked at a lot more regularly. I'm just joking. I look at it with great interest every semester. But they said, Professor Allen, you're killing us. You just come and lecture all day. What we would give for an in-class exercise. Well, today's your lucky day. We have calculated the start date, the start column. I want you to calculate the end column. I'll give you 4 minutes. 4 minutes is probably not enough, but I want you to kind of look at it and go, and the clue is it's really similar to calculating the start column. If you have a question or you want to think about it or kind of bounce something off me, let me know. Oh, you know what? I guess there's no reason to record this. Poor guys in YouTube. Not like they can't fast forward, but let's pause record. Okay, so there are a couple of different approaches that I heard happening out there. One is to say, let's just figure out how long the class is. So let's just figure out a date difference between the start time and the end time. And the truth is, that's probably my favorite approach. But that requires more thinking than the other approach, which is, let's just calculate the end time. Because calculating the end time is exactly like calculating the start time. So much so that I'm probably going to try to do it without even thinking. I'm just going to copy these variables. I'm going to copy these. And then I don't even do a find and replace. Find start, replace it with end, only the selected text. Do it again down here. Oh, thank you. Oops, in the selected text. Now I don't have selected text. In the selected text, there we go. It might have been faster to do it by hand. End time. And let me, oh, I should have done this too. All right, so I'm going to just try to run that and just see what it produces and see how we are. Oh, there's no cal end, so that's got to be, this has to be cal start. That's what happens when you don't think about it. You make mistakes like that. But you do need to be careful. Kind of expected something different than the same thing. Oh, thank you. Another thing is I'm looking in column I, but my end value is in column J. So now my end minute is, so my start minute is 270, my end minute is 374. It's like a 75-minute class, I think. That looks about right for 75 minutes. Now let's just check the ending column in 38. I just selected where my ending column is supposed to be. Active cell, dot column, 37. Yeah, so I'm off by 1. And that's because, you know, I'm coming right up to this minute, but not kind of going over. And we're going to have some classes that don't fall right on the boundary. Most of these do fall right on the boundary, but we'll have some that don't. So, you know what I'm going to do? Even though I really haven't thought that much about it, I am going to subtract 1 when I calculate my end minute divided by 15, my end column. I'm going to subtract 1 off of this. And is that the right place to do it? That should give me 37. I think that'll be okay. But I'll want to, because I did that really without thinking through all the logic of what I've done, I'm going to want to make sure I take a close look at several of these and make sure it's coming out the way I think it should be coming out. Okay, so now I think we've calculated what we need. We've got the column this bar should start in, the column this bar should end in. We know the row because the row is getting passed in. So I think we're ready to write out the, I guess we don't really need to be printing. I'm going to get rid of these now. I think we're ready to write out the bar. So to do this, I think we saw this, but let's take a look at it again. I'm going to use a different way to make a range. Range, R-A-N-G-E. And I'm going to give it 2 arguments. Instead of giving it a string that tells it what the range is, I'm going to give it 1 cell to start in, which is sheet 1 dot cells, row number, row, column number, start column, start column. So this is 1 cell. That's the beginning cell. And then I'm going to drop the ending column in, kind of the same thing, but everything the same except it's a different column, ending column there. And that should give me a reference to the range that I want to manipulate. So I'm just going to set the interior color. Now, there are like 16 million colors. And I'll take this question and we'll talk about setting the color. Oh, it's right here. I was kind of wondering why you didn't have that. So this one should be plus, thank you, plus my start, my cal start, right? Thank you. Okay, so that's going to give me the proper ending column, starting ending column. So I actually put it in the debug.print. That's where I put it. Delightful. I should have thought a little more about it than that. Okay, so now I'm going to set the color. So this is kind of a long, ugly line. But this is the range that says that the multi-cell range that I'm talking about. It has a property called interior, which also has a property called color. There are 16 million, more than 16 million different colors. And they are numbered 0 through 16 million and something. 0 is black. 16 million is white, and you know, there's some others that you might know. 255 is red. That's the only one I know. But I also know dark red. Dark red, almost a demonically dark red, happens to be color number 666. That's probably the same color that we have up there already. So I'm going to take these off. No fill. All right, so now I'm going to run this. I'll just run it right from here. F5, boom. And it is put there. Did it do it right? 12:30 to 1:45, 15 minutes, you know, ending 15 minutes before the 2 o'clock hour. Excellent. Let me kind of come up here to my Acme subrunner and do row number 3. And is that right? 9:15? Yeah, 9:15. Now, we're going to have some issues because some of these down here end at 4:50. That's not right on a 15-minute mark. So we don't have that kind of precision with what we're doing here, but I think it's probably okay because we're trying to get we know something about the way these classes get scheduled. You know, it's not like this class starts 5 minutes after this one starts, or they usually run in these kind of blocks. So I think we'll be okay, these large blocks. So I think all we have to do is, yeah, I think we just got to call make schedule. Let's run it. Bloop. And there we have the schedule and the visual representation of that schedule. Questions? So it's kind of surprising when it takes all that time to do one and it takes no time to do them all. I mean, the rest of them, once we've got that figured out. One more thing I want to do here, but I think it probably won't take the 10 minutes that we have left in class. We might even still get out just a few minutes early. Now, this really doesn't help us with the problem of knowing which classes are scheduled against each other. Why not? Different days. Yeah, so are these scheduled against each other? I don't know. Some of them are on Monday and Wednesday. Some of them are on Tuesday, Thursday. Some of them are on Friday only. So what I'd like to do is make one more adjustment here. And that is, not only am I going to tell the row that I want to show here, but I'm also going to tell the day that I'm interested in. So I'm now bringing in another variable, day as string. So let's go ahead and send in here a Tuesday. So capital T is what means Tuesday. Incidentally, capital R is what means Thursday over here. So TR actually means a Tuesday, Thursday class. I'm going to put a similar statement for right now down in my make schedule because now I've got to, every time I call show one class, I've got to send both those values because I now have two variables that I'm expecting to get their values from. So now here it might make a little more sense to use the names of those, row colon equals and day colon equals, but the order is fine as well. So now I only want to print the bar out there if the day that gets passed in is in column H. So if there's a T in this, if I pass in a T and there's a T in it, I got to paint it. If it's MW, I don't paint it because I'm only interested in seeing the ones that are on a particular day. Because now I want to look at it and say Tuesday. What conflicts do we have on Tuesday? Look at those and go, that's okay. Wednesday, what do we have on Wednesday? Look at those. Are those okay? There's a question here? Yeah, so here's the call to the show one class from inside my loop. And I'm just passing the second, a value to the second parameter here. Okay, so now what we're going to do is we're going to come here and say, listen, right here is the line that we're getting ready to print this thing off on. Right here's, this is the line that we're showing this up to the screen. I only want to do that on the condition that column H on my current row contains the day letter that was passed in. Right? I've captured that in this variable, and so I can use that to look at that. So this actually requires a couple things that we haven't seen yet. So this might make your head hurt a little bit. We'll spend substantial amount of time on both the new ideas I'm introducing right here. If, so this is conditional branching. If something is true, then we're going to execute this line, and if. So I'm going to put something in here that evaluates it true or false. If it's true, we'll execute the line. If it's false, we'll skip that line. And so there's a function built into VBA called instring, INSTR. Let me come up here and just show it to you really quickly. INSTR. Instring allows me to look for the occurrence of one string inside of another string. That's why in string is this one string inside the other. The order of the arguments here is a little bit odd, I have to confess. The first thing says, where do you want to start looking in the string, which we haven't identified yet. And I'm going to say, I want to start looking at the first character. Imagine that I've got this huge long string. I don't care about the first 1,000 characters. But I want to find, after those first 1,000 characters, I want to find the next occurrence of something. That's what the first argument is. But I want to start at the very beginning, so I'll use a 1 here. Now, I'm going to look in a string here, say, look in Nephi. And look for hi. And that will tell me where the second string occurs inside the first string. There's the first character, second, third, fourth. See how it starts in the fourth character? So it's returning to me where one string is found inside the other. What if it's not found inside the other? It returns 0. That's how it says it's not there. So I'm going to say if in string, and I'll put the parameters in there in a minute, but if that is greater than 0, that means it found it. What am I looking for? Starting at the first character, looking at my day, which is in column H. So sheet, cells, row, column H. And then the value I'm looking for is in the day variable. Got passed in to my day variable. So now I'm saying if the day I'm looking for is found in the set of days that this class is taught on, that's when I want to display it. So let me come here and kind of clear off my days. And we'll add a line to clear this automatically for us. But I'm going to clear that off. Oh, curse. And we'll run the loop again. And so now it should, every line that we look here should have a T in all those. That's the junior, that's the accounting junior core, meets Monday through Friday. So those are all there. No Thursdays, no Tuesdays. There's the next Tuesday. That looks pretty good. These are ones I didn't copy. These are ones I didn't delete from before. So let's just, when we start this loop, let's start off by clearing what used to be there so we don't have anything left over on it. So just before I get to the loop, I'm just going to say sheet1.cells. Now you're used to telling it which cell you want. Row number 1, column number 44. But it turns out if you don't tell it anything, it just means all the cells. Dot interior, dot color. Turns out of all those 16 million colors, they're all colors. There's not one that says no color at all. If I want to get them off, I do it with a property called color index, and I set that to XL none. So XL none says is the way that we say, no color. So if I were just to execute that, we would see that it would take off all the background colors. So now when we run the loop, it will take them off, put in just the ones for the days that we're interested in. If we change this to a Wednesday, it'll show all the classes that meet on Wednesday. Friday, all the classes that meet on Friday. And so that's a pretty reasonable thing to do. So, here in a little bit more than an hour, we put together something that would be pretty useful. Is there more that should be done here? Yeah, there's a few more things that should be done here, but we only had an hour. So, yeah. Questions? All right, thanks for coming. Class dismissed.